an earthquake? It's what happens when two blocks of the Earth slip past each other. And the surface where they slip is called the fault or fault plane. And you can see in these animations the different directions in which the blocks can slip, and these are different types of faults. And when this slip occurs, energy is released in all directions from the earthquake source and the source of waves, and these waves make the ground vibrate. In the case of the recent event, most of you probably felt earlier this year, it was a strike-slip fault, meaning that the two blocks slipped horizontally relative to each other. And this can be clearly seen in this picture here, where the road was cut in half, and there was a relative displacement between the two sides of about 3 meters. But at other locations from the same earthquake, this reached up to 8 meters as well. But what do these blocks of Earth move? Well, to answer this question, we'll first take a look at the Earth's interior. The Earth is made of 4 major layers that have different thicknesses and different physical properties. The crust, the topmost layer, which is where earthquakes occur, is 100 kilometers thick. So compare that to the radius of the Earth, which is in the order of 6,400 kilometers. So as an analogy, we can compare the Earth with an egg, and the crust or the lithosphere is similar to the rigid shell around the Earth's surface. And this shell, this lithosphere, is actually broken into many different pieces, which are the tectonic plates. And these plates are driven by different phenomena, and they slowly move relative to each other at different rates. The edges of these plates are actually not smooth. They are rough. And because they are rough, the plates, while trying to move relative to each other, they get stuck. And when they're stuck, energy is being stored. And then at some point, the energy is released. And this release of energy occurs at faults and is what causes earthquake. And here there's an analogy between a block sitting on sandpaper, so on a rough surface, and then at the beginning, when the rock is being pulled, it doesn't move, energy is being stored, and then at some point friction is overcome, and the rock slips, and energy is released in the form of seismic waves. And this phenomena and tectonic plates moving is what explains why the Earth looked as a single supercontinent 225 million years ago and evolved into what it looks like today. You've probably heard of a magnitude associated with earthquakes. So the recent events were magnitude 7.8. And this is a measure of the size of the earthquake. And it's unique for every earthquake, no matter where you are or how strong or not you feel the earthquake. And it's actually related to the amount of energy that's released by the earthquake. It depends on the rigidity of the rock, where the break happens, on the distance that the slip between the two blocks, and also on the size of the surface that moved and that ruptured. Basically, if you have stronger material, or you have a larger area that ruptured, or if it moves by a larger distance, then this will result in a larger magnitude earthquake. How often do earthquakes happen? Actually, they happen quite frequently. We have about 1 million earthquakes of magnitude 2 that occur every year. And these are earthquakes that we actually almost never feel. And with every 1 unit increase in the magnitude of earthquake, there is a factor of 10 decrease in the number of annual occurrences. So for magnitude 7 earthquakes, there's about 18 of them that occur on average every year. With every unit increase in magnitude, there's also a 30-fold increase in the amount of energy released. So you can imagine the incremental, exponential increase in the amount of energy released. And for comparison, the Beirut blast released energy that amounted to the equivalent of a magnitude 4 or 5 earthquake. So a magnitude 7 event would be about 1,000 times more energy being released. Zooming in on our region, so we're located here, and the East Anatolian Fault, the EAF, is where the large earthquake happened in Turkey in February. And in our region, we have 4 major tectonic plates that complexly interact with each other, that move relative to each other. And this is the cause for the earthquakes in our region. In Lebanon, we're located along the Dead Sea Transform Fault, which you can see in the figure there. This is a strike-slip fault, so there's a horizontal relative displacement between the two sides of the fault. And this Dead Sea Transform Fault, when it passes through Lebanon, it actually branches out into multiple faults that include the Yamune Fault, which passes throughout the Bekaa, and the Mount Lebanon Truss Fault, which is slightly offshore of Beirut. And these faults have generated large earthquakes in the past. So based on historical records, there have been about 17 earthquakes documented in the past with magnitudes between 5.5 and 7.6 occurring in Lebanon or in the region. We haven't had major earthquakes in recent years. Since instruments were installed, we've had several earthquake events as well, as shown in the instrumental seismicity map, but no major ones in the past 100 years. Going back to why does the ground move when an earthquake happens, we already discussed that when the slip occurs, energy is released in the form of seismic waves. And these waves actually are of different types. Some of them travel through the earth, other travels along the surface, and they have different properties, different travel times. And when they reach the surface, this is when the ground starts shaking and shaking anything that is on it, like buildings. How do we record earthquakes? Well, instruments have greatly evolved over time. Technologies have evolved over time. And these are some pictures of modern instruments. These instruments digitally measure the ground motion, either the ground acceleration or the ground velocity in all directions. So in the north-south direction, the east-west direction, as well as the vertical direction. Traditional instruments, however, can be expensive and complicated to set up and maintain. So in recent years, there have been low-cost instruments, such as this one, which have emerged. So these are really plug and play. All they need is power and access to internet if you want to send the data online. And they're very easy to use and maintain and operate. And so these can be useful in areas where we have no or not many traditional seismographs installed. And so I have one of these already installed in my office, and I have two more that I want to install on the AUB campus. And while trying to find a good place to install one of these on campus, I did some research, and I found out that actually in the Lee Observatory, this building you may be familiar with, which used to house the telescope, actually in the 1900s, Robert West had installed a Milne seismograph, such as the one you can see here. And this is some of the earliest recording instruments, and it used to record the waveforms on photosensitive paper. And I haven't found these papers yet. I'm trying to see if there are any still remaining from back then. And this is what the instrument in my office recorded on February 6th. So you see the velocities in the three directions, the three components, and they reached amplitudes of about 2 centimeters per second here on the 5th floor. Actually, the ground shaking varies significantly from one earthquake to another, from one location to the other. And you can see here some waveforms from different events at different locations. And you can clearly see differences in their amplitudes, in their duration, as well as in their frequency content. Even for the same earthquake, as I said, even though it has a single magnitude, but how it's felt varies from one place to another. So this is a map that shows the intensities, the felt intensities of the earthquake on February 6th in the neighboring region. And in Beirut, it was felt in the order of 1 to 2 centimeters per second velocities, while closer to the source, it had the shaking had intensities of 20 to 30 times larger. So what controls ground shaking? We already discussed actually two of the factors, magnitude. The larger the magnitude, the more energy is released. So you'll have longer and more intense shakings. And with distance, shaking tends to decay. Another very important factor are actually the local soil conditions, the local sites. And softer soils can amplify the shaking compared to bedrock. as also demonstrated in this animation here. How about buildings? How do our buildings respond and perform in the event of earthquakes? What does their response depend on? Of course, it's going to depend on the shaking itself, its intensity, its duration, its frequency content, but also on the characteristics of the structure. What type of structure? How well is it designed and constructed? How high is it? So all these are important parameters. And this can be clearly seen in this picture from Turkey, where you have completely collapsed buildings, and next to them, some buildings that seem almost intact. So final section, what do ground motion's waveforms reveal? Well, they actually have a large number of applications, a large number of uses. They are used to locate where the source of earthquakes is, and also to determine the properties of the earthquake sources, such as their magnitude, the geometry of the fault that ruptured, the mechanism of the rupture as well. They can be used, if enough data is collected, to develop predictive models to predict the intensity of shaking if an earthquake has occurred. So we can predict the peak ground accelerations for a certain magnitude event at a certain distance, or even use data to generate synthetic ground motions that replicate the characteristics of recorded ones. And these can then be used to develop seismic hazard maps that are used in building codes. These waveforms can also be used as input to structural analysis models of buildings to analyze, design, and assess different structures. And a final application here is they're used to issue early warning alerts. So this is not an alert that predicts that an earthquake is going to happen at some point in time. It's just an alert that an earthquake has started and the shaking is going to reach you in a few seconds. So be careful, be ready. I'll end with preparedness steps. So what to do if a large earthquake happens nearby and you feel strong shaking? Well, the first thing to do is to drop cover and hold on. If you're indoors, stay indoors. Shelter under sturdy objects, under tables. Stay away from windows, from potentially falling objects, because these can be a cause of injuries. And if you're outdoors, stay outdoors. Move away from buildings, because these could also cause falling debris. Move away from electrical wires that have fallen. And you can find a lot more tips on what to do before, during, and after an earthquake in the AUB preparedness document, as well as in many other sources online, such as the CDC. And thank you for your attention.
So our next speaker is Professor Ali Shab. Ali is a professor and the chairman of electrical and computer engineering. And he does research in security, but he also uses machine learning in his research. So he's going to tell us a little bit about ChatGPT, which is a new platform that emerged early this year, everyone's talking about. And he's going to tell us a little bit about what does ChatGPT mean in terms of the future of conversations with artificial intelligence.
Hello, everyone. Nice to see a large crowd. And as Mazen mentioned, they gave me a tough topic, a very tough topic. Why? Let me start by saying that the people who actually designed and working on ChatGPT, they don't know how it works. So no one is going to claim, "Wallah, nahna rabba ChatGPT." No, no one knows what's actually happening. One. Two, there is a lot of controversy, as I'm going to mention. There are many things that are advantages, disadvantages of using large language models and so on. So as much as I can in those few minutes, I will try to give you a very shallow idea about the topic and the issues and the controversy around large language models. Okay, so we'll introduce quickly the concept of large language model and what is at the heart of ChatGPT. What is the true power of ChatGPT, and what are the limitations, on the other hand, and the issues related to ethics and other issues as well. and the future of large language models. Now, I just want you just to keep in mind, since I'm going to talk about pros and cons, always keep in mind that the pros assume a quote unquote a proper use of ChatGPT and large language models, because everything could be abused, including those LLMs. So when I mention something positive, that's assumed that people are aware and are actually properly making use of ChatGPT. So what's it about? So the main core and the main technology behind large language models is something, is an architecture called a transformer architecture. A transformer architecture is basically a neural network, a huge neural network, which consists of millions of neurons. We can simplify the concept of a neuron as a very basic mathematical function. And in between all those neurons, the millions of them, there are billions of interconnections. And these links are kind of weighted, meaning that, so each neuron take a combination of those links, and there are billions of them, applies a basic mathematical formula, and then comes out with a value that gets passed to the second level of neurons and so on. And you can have thousands of levels, millions of neurons, and billions of interconnections. And what is interesting about such a model is that people who try to design such a model don't actually design the model, because the model designs itself. I know it's scary. You put this as monster, you set up this monster, and as you feed it with data to learn, it's gonna learn, and as it's learning, it's adjusting all the weights on all the different links, and then it's as you give it more and more data, it learns more and more, and this model builds itself incrementally. And the architecture of a transformer is an architecture with this huge model of neural network that actually learns like you know, like a text in a sequential manner, and keeps on building and building and building. So large scale training, yes. So the ChatGPT to reach what it is today, it was offered huge computational power, and it was offered massive amounts of data. And this data is either textual, books, articles, websites, and so on. The other thing that about ChatGPT is customization, meaning it can actually understand language style and imitate diverse personality. So again, which is excellent for a good use, not so excellent because you can customize ChatGPT, and you can imitate anyone that you want, and you can get let's say you can come up with just as a simple example, with an audio with your probably your famous singer and so on, just talking about the positive things. So it can learn to actually understand a style and imitate personalities. And lastly, contextual understanding. What does this mean? As you know, there are so many different languages around, but if we stick to English, every language has a different kind of characteristic. And what is interesting is that a large language model was actually capable of understanding the linguistic context. So given, let's say, a large amount of text, it can really understand what is important inside this text, and to focus on exactly this particular piece of the text in order to learn more and improve its the way it's working. So, as I mentioned, we have enormous amount of data that has been used to train ChatGPT. Yani, to put things in perspective for you, you know, if you have a mathematical function, it may have some parameters, right? So we said that here we have millions of simple functions and billions of probably inputs. And the parameters as such become huge. So we're talking about 175 billion parameters. Can you imagine the scale? You have a function in general that depends on so many parameters, billions of them. And this is one of the things why the people who created this monster do not really know how it is evolving, right? Because it's teaching itself, tuning those parameters, okay, the way it thinks it's the right way of doing it. The second issue is that the data come from many different sources. So it comes from books, from articles, so websites. You can give it, it can get its hands on whenever you offer it, and it will make use of it. We're talking about if a human wants to read all the data that was given to ChatGPT, it will take a human continuously reading around only 10,000 years to consume all of this data. And in terms of size, we're talking about 570 gigabytes of text. That's how much it was given to train ChatGPT. So we're talking about 800,000 books together. Okay, when did we first started to get an idea about large language models? Well, for example, in Google's query auto-completion, you start typing something and Google completes the sentence for you, right? Or give you suggestions. This was our first encounter until we reached where we're here today. And again, the large language model by nature are probabilistic, and they started gradually. For example, the first thing and the easy thing at the beginning is that to predict, given the context, is to predict what's coming next, and then thing will start to improve, and it infers word probabilities from a particular context, okay? And the most important thing about transformers nowadays is the word attention. So we said that we have those neurons and those links, and you have hundreds of millions of links connected to neurons. So as it learns, it starts to pay attention to some of the links more than others, depending on the context, and it trains itself accordingly. So it pays attention to some, let's say, features, and making them or labeling them as important features relative to other features and so on. And they can grow in complexity as much as we allow them to grow, as much as computational power we give them, and as much as data that we give them, okay? And those large language models, okay, they have a great deal to teach us if we use it properly, okay? I'm not going to talk now about the advantages. I'll keep it in a minute. So the power of ChatGPT, again, assuming a proper use of the large language model, is to improve the learning experience. Here I'm talking from an academic perspective. So personalized learning experience, you can start chatting with this model, and you can provide this model with some context, and then it will start providing you with information that you are actually looking for. So when you provide it with enough context about yourself and what you're doing and what you're trying to study, it will actually lead to what we call personalized experience and personalized learning experience. Self-criticize ideas. So again, you start chatting with this model, you give it a number of ideas, and you ask the model to actually assess their advantages, disadvantages, especially let's say you have a startup and you want to do that with a couple of ideas, you're not sure which one is better from either technical, from impact, from etc. So you can start chatting with the model, providing some context, the ideas, and ask the model to assess the ideas until you eventually converge on which one to go with, okay? A practice for exams. So you can ask actually this model some questions related to whatever subject you're studying, and you can try to ask ChatGPT itself to imitate your course professor. Okay, he's teaching us this, and that. So what do you expect he is going to ask us as questions? It will prepare a practice text for you. So not bad here, okay? And it also helps you in reasoning in problem solving, which is also nice. Why? Because instead of saying, okay, listen, I have this problem, it's tough, I can't solve it, what's the solution? No, you can ask them a model to actually walk you through the solution, trying to understand how to think about getting the end result, which is the solution for the problem. And I think if used properly, this is a very interesting advantage of ChatGPT. Also, you can it can be used to improve the consultancy industry, and maybe maybe these are one of the jobs that can be terminated by ChatGPT. I hope I'm not offending consultants in the room. But we as engineers, we like our engineers to go and make a change in the world and not write PowerPoint slides. So ما تزعلوا مني يعني. That's the way I am. So you can assume the personality of a CEO, CMO, whatever, and you can ask GPT to debate a particular topic and to critique all the ideas being put on the table, let's say by your team, and until you are convinced with a particular way to go, let's say a strategic decision about a company or a consulting job, إلى آخره, and it can give you a high quality deliverable. That's not bad, because that's what consultants do, right? So given a certain problem, and there are some, let's say, strategic decisions to be made in order to reach a particular goal, and to do that, there are many mechanisms to do it. You can propose all of them to ChatGPT, provide enough context, and ask for the pros and cons of each of those mechanisms until it convinces you, well, if you go this way, that would be the most, say, cost-effective or most impactful, and so on. Okay? So it can do a lot. Coders probably in the room are enjoying the code generation, because you can, it does not give you perfect code, but at least it gives you something to start with. And all what you need to do is to solve a particular problem. You get the code, and you just need, to tweak it here and there, and your code is almost ready. Project management, no, it's not going to put you to Jamaat project management. You're okay, you're safe. But we can we can ask ChatGPT to help us in there, in design exploration, optimization, product documentation. That's very interesting, because documentation is something that is painful. Okay, no matter what industry you are, whether it is code documentation or others, ChatGPT can help you properly document whatever you're doing. And if we want to leverage the true power of ChatGPT, that is, if we use it properly, okay, this would require a mind shift. Why? Because it's very important to raise awareness about the capability of ChatGPT, and the good and the bad, if you want to. And just to give you an idea, every time I'm saying bad, actually, I want to use a very nice example that one of the professors in our department just told me about yesterday. He was asking graduate students to do a literature review about a particular topic, and the student asked ChatGPT, and ChatGPT replied with a number of publications with top-notch authors in this exact field, with some very good titles about their publications and excellent venues in terms of conferences and journals, and all of them turned out to be fake. So you have to realize this issue. And no, ChatGPT, you ask it to write an essay for you, okay? It will do that. If you ask it for a paper about a particular topic, it wants to give you an answer, right? So it thinks, who is good at this topic? This author, tamam, what he would do, it proposes something, so that's a title. Where is a good venue for this conference? Haida. It gives you something that you would think it's real, but it's not, all right? Just made up. So that's why it's very important for people to know what's available and what is true and what is not true in that context. So that's why there is always a limitation at the moment about using ChatGPT. And in order to put this, I'm going to skip this a little bit because I want to get here. I know we do not have a lot of time, so I want to stop here at this particular slide. Okay, so here we have Pope Francis wearing a puffy jacket. That's not a harmful picture, but it looks very real. All right, and it has been generated by AI Mid-Journey. It's an image generator, and I mean that's fine. They wanna the Pope to look like wearing such a jacket. Measure hal, it's okay, but this can be taken much further, and whatever is fake can be more dangerous, and so on. And for that particular reason, there are more than 1,000 specialists in the area of AI who are actually warning about the use of AI, to putting regulations in order, or at least to stop immediately for a period of 6 months, because technology is advancing very fast. The regulators are usually very slow, so they want to stop this technology immediately to give time to the regulators, at least 6 months, in order to regulate this thing. And because they see this as dangerous as nuclear weapons. And the people who are proposing this, as you can see, they are comparing this AI large language models as people trying to create a digital god in some sense. And also they're saying it's one of the dual class technologies like nuclear power or biochemistry. So which means even the peaceful use of it needs to be regulated. This is how dangerous they see it. And that's why it's important to, for this technology, no one is going to stop it, because the high-tech companies, everyone wants to beat everybody else to the market. And if you forget about ChatGPT, there are already dozens of AI-based tools, from designing a website in double of clicks. You say, what is your business? And you give a couple of sentences, poof, your website is there. You want a nice-looking image, you just put the contents and poof, it's there, etc., etc., etc. So everybody is trying to compete with everybody else in order to go to market with those generative artificial intelligence kind of things. And one last thing here about ChatGPT, even though it is powerful and can give us a lot of things, but Kamena, if you want to talk about the environment, okay, ChatGPT consumes a lot of power. Because as I mentioned, when you give it this tons of processing powers and millions of processors running, okay, they say every 20 to 50 questions you ask ChatGPT, it consumes one fresh bottle of water. So that's a lot for 20 to 50 questions, right? So here, 500 milliliter, 20 to 50 questions, it is actually consuming. So it is a thirsty type of artificial intelligence. And we need to watch for this thing. Ethical considerations, a lot. We have many things, especially we need to worry about potential hallucination, meaning giving false information, and but with accurate details that where you might think, wow, it's going to be very hard for you to know that this is really fictitious until you go and dig deeper somewhere else. You can take it at face value and use it, and that is not good, all right? If you don't do your research after taking this information from ChatGPT, you are basically at risk. And I think I'm running out of time. The future is huge. There are many things that will happen when this capability is going at high speed. And there are many research areas. One of them is the carbon footprint. That's very important because of the consumption of all these tons of processors and servers and racks of servers and huge data centers running ChatGPT. And I guess with that, I'm going to stop. And thank you.
keeping with the theme of machine learning, we know that the quality of a machine learning model really depends on the data that we use to train the model on. And one of the big problems here is bias in the data set. So here to tell us about bias and how to address it is Professor Maher Nwayhid from Industrial Engineering.
Okay, so good afternoon, everyone. Thanks for attending. So I'm going to also talk about machine learning in this session after the session on ChatGPT and after Dr. Ali showed us the computational power and how useful these tools or how powerful these tools can be. I'm going to talk about a specific niche or specific aspect of this machine learning, which is fairness in machine learning. So I'm sure that almost everyone in this room have used or came across some application that requires using machine learning models. So be it voice assistants like Siri, being Face ID, or even in the healthcare industry, where you give it an image and it gives you a probability map of where you have a high probability of having a tumor or something like that. Okay, so you can see these applications in enormous amount of industries. This is, for example, a Tesla car on autopilot. So you can see how powerful these applications can be. It's actually detecting all the vehicle stop signs here and using the input from the sensors and from the cameras in order to direct the cars and stop the cars in the right places. Okay, so you've encountered these or similar applications in a lot of different ways. For example, recommendation engines, when you use Netflix, they recommend some movies. Recommendation engines in Amazon, when you buy a product, on YouTube, many other applications, and they're very powerful. However, with great power comes great responsibility. So how should we use these applications in a good or fair way? The question that I'm going to try to answer today is, can we blindly rely on machine learning? Actually, there are a lot of recent applications or instances that have showed that these models, when used, can actually discriminate against a certain group. One would expect that when we use a machine, that this machine doesn't have any prejudice, does not discriminate, is objective. Okay, so they would think that it's more fair than a human, which can have a background, a bias, or whatever. However, recent applications have showed the opposite. One example is this machine learning algorithm that was used for risk assessments in criminal sentencing. And this is used in the US, and the algorithm is called Compass, and what they use is to predict the defendant's likelihood to reoffend. So they give every defendant a risk score. What's the risk of reoffending for that defendant? Data have showed the following. For example, for African American defendants, this is the risk score. So this is the distribution of risk scores. They used 7,000 defendants to plot this distribution. You can see that, for example, around 200 defendants they had a risk of around 10, around 300 have a risk of 9, and so on, versus the distribution for white defendants' risk score. So almost like 60% of the defendants, they were risked with very low score. So there is a skew here, a skewed distribution towards low risk. However, for African American defendants, it's more distributed. And when you dig more into the data, you see the following. If you look at the labeled high risk, but defendants that do not reoffend, it's around 23.5% for white compared to 45% for African American. So around 45% of the defendants that were labeled with high risk actually did not offend, compared to 23.5% for white. So blacks are almost twice as likely as whites to be labeled a higher risk, but not actually reoffend. So they realized that these actually models can be biased against certain protected groups. They can be racist. They can discriminate against a certain group. They can be gender biased. Another example is a machine learning algorithm used by Amazon to give scores for resumes for new candidates. So you give them the CVs. You can imagine the number of CVs that get submitted to Amazon. They just give them a rank, okay? And what happened is that they realized that it's biased for men. So due to the male dominance of the tech industry, most of the candidates suggested were male. And digging more into the details of this, they realized that the algorithm was actually penalizing for words like women. So because the data is biased, it doesn't have to do with the machine. But because the data is biased, actually what is happening is that the algorithm is trying to learn based on the data that's given, and it's seeing an easy escape to say whether this is a good resume or not, and the easy escape is gender, okay? Because of the data that was given before, it's seeing that, okay, if it just say give higher probability for men, less probability for women, this is an easy escape to get high accuracy. So this is why a lot of researchers have looked recently into what we call algorithmic fairness. So imagine that these algorithms are used, and they're used in our data applications and affect our lives. So who to hire, who to fire, who to take into a graduate school, who to give loan, who to give insurance. Imagine these algorithms used in these very important applications, and imagine if these algorithms are biased, then you can think of the disasters that can occur. Also, if these algorithms are biased, the data that's being generated is also more biased. And this is a loop that will take us to more bias and more bias as we go. So at some point, we have to stop and actually look into how to design algorithms that are fair for machine learning. To talk about this, the first thing we have to define is what is fairness. Like, what should we say about what is fair and what's not fair? I put some definitions, a lot of definitions for fairness in machine learning algorithm, in machine learning field. One of them is demographic parity. This comes from what we call the disparate impact doctrine. It's embedded in the laws for the US. And what this is saying, it requires the model output to be independent of the sensitive attribute. So the sensitive attribute can be gender, race, or whatever. We want the output of the model to be independent of that. So regardless of what the sensitive attribute is, the model should give the same output. For example, look at this data set. Imagine that we're trying to say whether the applicants will pay a loan or default. This is a group A. They can be males, females, or whatever, high income, low income, whatever. And this is a group B. And these points are plotted based on credit history and income. The shallow points are points for people that defaulted, and the dark points are points for actually people that actually paid the loan. And we've trained a machine learning algorithm to learn on this, and we get, for example, the following solution. So these are loans that are denied, and these are loans that are denied, and these are loans that are granted. So the algorithm is trying to say that people with high income should be granted the loans, otherwise they shouldn't. If we look at the positive rates, so here 5 out of 10 were granted loans for group A. However, 5 out of 8 were granted loans for group B, and it seems that the percentages are different. Demographic parity would like to see something similar for group A and B. So here, half are granted loans, here half are granted loans. So out of the applicants, if we have, for example, males and females, so 50% of the males, for example, are granted loans, then 50% of the females should be granted loans. Something like they should have the same percentage of acceptance. So this is considered unfair under the demographic parity. This is considered fair. Another example is equalized opportunity. In equalized opportunity, we actually require the true positive and the false positive rates to be similar between grades A and B. So if you look at the dark points here, 3 out of 4 were granted loans, but here 2 out of 3 were granted loans. So we have different percentages. Changing the model acceptance will make the true and false positive rates equal. So we want to train a model that gives similar positive rates or similar true positive rates or false positive rates among different groups. In simpler words, the behavior or the model accuracy for different groups should be similar. It shouldn't be performing well for one group and bad for another group. How to train models fairly? In literature, there are 3 types of models or mechanisms or methods that allow us to train machine learning fairly. Pre-processing methods, post-processing methods, and in-processing methods. What pre-processing methods do is actually they try to modify the data. They change the data a bit so that once it's trained, it's fair. In post-processing algorithms, they try to modify the predictions. So they change the values of the predictions to make the models fair. And in in-processing methods, we actually design algorithms so that the algorithms are actually fair. So for example, in the pre-processing, one will think that the simplest solution is actually when you're giving the data, remove that attribute. So don't give it the gender. Don't give it the race of that person. However, this has shown that it doesn't always work because the model can learn from proxies. So imagine that you remove the color, the race, okay? And there is a certain city where in that city 80% are black. Okay, if you give the city for the algorithm, it will learn it through the city. Okay, so there are proxy attributes from which you can learn and actually be prejudiced or discriminate against a certain group. So there are more advanced techniques where they actually bring the data, transform it to another domain, and that domain, things are fair. You don't have any, you remove all the correlations between the data and that sensitive attributes. So now the data is fair. And then you apply any algorithm and it should work. Because the problem is not in the algorithm, it's in the data. Another method is the post-processing algorithms. And what they do in this case is that they change the thresholds for different groups to make things fair. For example, if you train an algorithm and say everything above a certain income will give him a loan, you change the thresholds between, for example, females and males to make the output fair. The third thing is the in-processing methods. So what we do here, and that's what I work on, is to modify algorithms or come up with algorithms that actually train things fair, even if the data is biased. So even if you give the biased data, how to develop an algorithm that actually trains the model in a fair way. When we talk about training machine learning models, we're talking about maximizing the accuracy or minimizing the loss of some model by tweaking some parameters. So Dr. Ali Shahab gave us an example on ChatGPT with hundreds of millions of parameters. There are more simpler models. There's these parameters that we tune and actually try to get with a model that has a good accuracy or a low loss. In fair modeling, we actually add another objective, which is a fairness measure. So we penalize the objective if the output is not fair. So whenever we have something not fair, we add this to the objective and we penalize it. So one example that we did is we actually add a correlation penalty. So if we have a correlation between the model output and the attribute, then that's where we pay a penalty. And this is what we get, for example. The more we increase the lambda or the concentration on this objective, the fairer the solution is. Now we extend these, or this idea can be extended to federated learning. And what is federated learning? Federated learning is whenever the training occurs at the clients. So nowadays we have a lot of smart devices, and these smart devices are computationally powerful. So imagine that you're using this smart keyboard. In that case, it's not possible to share your data. Or if you're using AI to do something in the images of the gallery, it's not possible to share the data. So in these cases, the data is kept privately on your device, and the learning occurs at your device. What happens is that they send the model parameters to an aggregator or a server. The data is not shared. They just aggregate the models. So in that case, we also add a fairness parameter, which actually measures the difference in the losses for different groups. So what we try to do is penalize the loss discrepancy between groups. A group with a higher loss than other group is actually, a model with that case is penalized more. So what we try to do is give more weight to groups that have high losses. So if a group is incurring high losses or the model is not accurate for that group, you need to actually give it a higher weight in order to improve its performance. So imagine you're using this smart keyboard on your phones, and you have two different groups using it. For example, one of the groups, the model is not working well. We train it with a higher weight for that group to make things more fair or balanced. Let's give an example. Let's say this example of smart typing. And we set the groups to these images. Images of capital letters, images of lowercase letters, and images of capital and lowercase letters. We know we need the model to perform well for all people. People that type in capital letters, people that type in lowercase letters, and people that type in both. So we don't want the model to be working well for some people and bad for others. And we can see that the range of accuracy is much better for when you train with fairness. Okay, so the discrepancy between the losses becomes much smaller. Okay, so these are just two types of models that train in fairness. There's a lot of literature on that, and that's it. Thank you.
All right, so we're going to switch gears now, and we will be talking next about sustainable design. So for decades, we've been hearing that we should reduce, reuse, and recycle. But it turns out that there might be actually better ways to do things. So here to tell us about this is Dr. Alisar Yahya from the Department of Civil and Environmental Engineering.
Hello, everyone. So I'm going to take you now on a journey to how we engineers can do things better, how we can go from being less bad into going to being more good. When we think about the future, we usually think about the tech revolution. We think about smart cities and smart systems. We think about the digital transformation. But there's another this was the bright side. There's another side of the things, where we have climate change, where we have more pollution, more waste accumulated, more fires, more disasters. So the usual and the most popular way of dealing with climate change is to actually reduce consumption, reduce waste, reduce carbon emissions. So the word that we hear most is actually reduce. But is that enough? Well, actually, the data doesn't show that. So if we take the example of fossil fuel production, for example, so the traditional way of seeing things is actually to lower the rely on fossil fuels. The red curve here shows the business as usual if we continue on exploring and continue in investing in fossil fuels. And the black curve here shows the scenario that is now taken into consideration where we start decreasing the rely on fossil fuels and actually not exploring new fields. And as you can see here, the blue curve shows the scenario and the strategy of production if we want to keep the limits of global warming below or at the average of 1.5 degrees Celsius. And we can see here very clearly that even with the reduction, it's not a solution. We're still going to go beyond the 1.5 degrees Celsius of increasing global warming. Then what we can do? So reduction is not the only way of doing things. So we want to rethink the way we design, and especially in terms of for us as engineers, because we are the ones that are responsible of putting there all these products and systems. And if we want to go beyond the less bad, beyond the idea of reduction, we want to think of positive impact, of having a positive impact and positive footprint, basically. So how do we do that? Through sustainable design. And there are three key principles or key elements that I think they are the most fundamental in terms of achieving a sustainable design. The first thing is life cycle thinking. So where we think about the materials and the products throughout their life cycle, we care about about the safety of the materials that we are using, safe for the environment and for human beings, and we care about what happens to the materials after the end use. The second fundamental key element is actually systems thinking and interdisciplinary aspect. We cannot think of sustainable design outside this holistic approach where everyone actually brings input in the table, whether they are designers, engineers, or in any field of science or humanities. The third thing which is important is social fairness. And we are still lagging a lot behind when it comes to social fairness and engineering, and especially regarding different things, the use phase, how our products and systems actually are affecting societies. The second thing is during the production. Are we considering what are the conditions of labor and workers during the production phase? And even at fundamental or the first day of the design, are we taking all the biases into consideration? And I think this is where we're still lagging. I don't know how many of you have heard the phrase shrink it and pink it, which is referred usually to gender bias, where we take, for example, traditionally designed products and systems for men, and which has changed the size and the aesthetics and made them for women without actually taking into consideration the actual safety and things that are specific for specific gender. So briefly, these are the main three key elements for a sustainable design. Now I want to take you on a journey from my own experience on how my own shift in design happened from being less bad, from the idea of reduction, to the idea to being more good and to have a positive impact through the design. So I will tell you the PCM story. So what is PCM? PCMs are phase change materials. They are materials that have a very high latent heat of fusion or very high thermal capacity during the phase change process. So what will happen is that due to the excess or increase in energy, these phase change materials will actually consume the excess energy, store this excess energy at constant temperature, and they use this energy actually to melt. And then during solidification process, they will actually release this stored energy, stored material at constant temperature. So they have been used traditionally to reduce, again, the word reduce, less bad, to reduce the energy consumption. And one application is reduce the energy consumption of buildings, because we know buildings are responsible of the majority of greenhouse gas emissions, especially due to heating and cooling systems in buildings. So the traditional way, or one way of applying phase change materials, there are several ways. One way is actually embedded in the wall, the building wall. We can place a thin layer of phase change materials. The phase change materials, as we said, they have very high thermal capacity during the phase change, and they are able to create this high thermal barrier and reduce the fluctuations in the internal temperatures, so that they would reduce the load or the amount of load needed from heating and cooling systems. The selection traditionally of phase change materials was based on the performance and based on the price. And most of the materials that are commercially available are hydrocarbons and are salt hydrates. So the first shift in my thinking is, okay, we're trying to decrease the greenhouse gas emissions, and now we're using products and materials that would actually emit during the production greenhouse gas emissions and have a negative impact on the environment. So the first shift was, let us look for materials that have lower impact. So if we from the study of the environmental impact of octadecane, for example, this is a hydrocarbon, or a salt hydrate, as you can see from the bar diagrams, the blue bar diagrams, they showed that environmental impact of hydrocarbons is very high. So we said, okay, let's go ahead and and hydrocarbons are not safe also for human beings, let's use a bio-based material, like, for example, coconut oil. And surprisingly, when we studied the life cycle, and there where life cycle thinking is very important, when we studied the life cycle of coconut oil, it turned out to be even comparable or relatively a little bit higher than salt hydrates because of the agricultural practices associated with it during the life cycle. Even if the material itself is safe, but if they would take into consideration the whole life cycle, there might be environmental impacts that are harmful on the environment because of the use mainly of chemical fertilizers. So the other way of seeing things, yes, if we don't use chemical fertilizers and we substitute that with biofertilizers, we can see that we have a substantial improvement in the environmental cost indicator or the environmental impact. And we looked the same thing for social stresses, because the sectors that are responsible of producing hydrocarbons and salt hydrates are the highest ones in terms of child labor, non-fair salaries, corruption, etc. So even in this sense, the coconut oil can be a better option. So we tested it in the lab, and we can see that the red curve shows the construction panels without phase change materials, and the blue one shows one with the coconut oil, which shows a good reduction in the energy required to actually keep in a comfort temperature. And again, this is the less bad approach. We're still in the reduction part. So the second shift in thinking, how we can be more good, how we can not only reduce the energy consumption, but use wasted energy, use freely available energy in order to actually substantially or not rely on any source of heating or cooling. So when we think of that, we can think of the heat from the sun, for example. But in this design, as we can see here, the phase change materials is placed before or after the insulation. So the insulation material is a material that creates a very high thermal barrier. So there is no contact, there's no communication with the outside. So the material is not able to store energy from outside to discharge it to the inside. So we can say, okay, let us put it in the other way. Put the phase change material here. So, well, the phase change material can actually get energy from outside, but it cannot discharge it to the inside. Then someone will come and say, okay, let us take away the insulation material from the beginning. That was not a good design as well, because phase change materials, when they're not changing their phase, when they are in the solid or liquid state, they are bad insulators. So they cannot take the role of the insulation at all times. They can be helpful when they are changing the phase. So the best option is, why not move it around? Like, why not create a system that is dynamic, where the location of the phase change material can change, within the system. And this is a proof of concept for this idea, without looking at what could be the system, what could be the form of the system. And as we can see here, if we go from a static phase change material system to a dynamic phase change material system, the black curve shows the system without any phase change material. The red curve shows the static PCM, the less bad option. And we can see that we have a reduction in the load, the needed energy for cooling. And if we look at the blue curve, we can see that we have negative Q load, a negative load, which means that it's not only reducing the energy consumption, but actually it's extracting heat from the inside. And this has been tested in a day where we have very low temperatures at night. So the system, the idea is appealing, and the idea of actually having a dynamic and responsive system can create a more good, not only reduce the consumption, but actually extract heat from inside. So the system that we have been developing is actually based on how we can actually create this system, make this system dynamic. So we propose to do cylinders, to have phase change materials placed in cylinders instead of having flat panels. And these cylinders can actually rotate depending on whether we want it to rotate to the outside or to the inside, having the insulation material as well. And the good thing about this system is that it can also host up to 2 phase change materials. Why would we need these 2 materials? Because what could be actually optimally used in winter might not be optimal in summer. So in this way, we can place more than 1 phase change material and direct the material in the way we want in order to actually get the best performance of the system. And we tested, of course, the system numerically in terms of to understand even if it works, or if the change in geometry by replacing the cylinders with the panels with cylinders would actually affect the efficiency of the system, and we find it to be very promising. But how the system actually would work, and this is where the actual shift in the design perspective. We have to think of the system, do systems thinking, and we have to bring everyone on the table to think about how that would actually work, because there is decision making when the rotation of the cylinder would happen. We have to monitor what is the outside temperature. We have to understand what are the conditions that would actually allow an optimal rotation schedule for the system. And there was where we built a team where we have different researchers that can work on basically developing, of course, the simulator, where we can generate a lot of data and optimize the data on 2 levels. What is the phase change materials, the optimal phase change materials? The second one, what could be the optimal schedule to get the most out of the system? And basically, if we're going to do this method or this optimization, then in real-time decision-making is very complicated. So we want to understand how we can, or we want to create an algorithm, like we can use machine learning here to actually understand or get the monitoring data, because we have to understand what are the actual conditions of the outside and inside, and the actual condition of the systems, and the optimization data, so that we can do a real-time decision making. And with this, we can go from actually having all the data available to the idea of having some missing data, to the idea of actually collecting actual performance data and apply reinforcement learning to actually predict, or have a reward system to predict what could potentially be the optimal schedule of rotation. Briefly, what I wanted to convey here is that monodisciplinary cannot solve complex problems. And the critical key element of sustainable design is actually having everyone on the table, discussing together and creating a solution that actually involves engineers from different disciplines, scientists, even social scientists, to address social fairness, and all together we can bring up a complex solution for a complex problem. So the takeaway message that I have is that for sustainable design, we have to design together. We have to have engineering from all the engineers from all disciplines. We have to design for more, not only design for reduction, we have to design for a more good, and also design for all, take into consideration all aspects of societies and remove all biases. Thank you.
We know that Lebanon is a country of great natural beauty, but it also has a lot of architectural gems. And our last speaker today will be telling us about renovating one of those gems, architectural gems. So, Nicholas, the floor is yours.
Thank you. Preserving heritage is not only protecting walls in a field of ruins, it transgresses the history of men and women, the memory of our humanity, and it's one of the most tangible dimensions of our identities. We destroy and we then mediate. But this heritage is also synonymous with hope, because heritage can be a vector for economic growth and social development, and even more so, sustainable development, because very often at the heart of our ecosystems and territories, it can divide, but it can also bring together, create dialogue between cultures, religions, and it can thereby contribute to building a better future. This is one of the ambitions of the renovation of the guest house at the International Tripoli Fair that was designed by Oscar Niemeyer in 1964. You might not be familiar with this project, maybe some of you are. It's one of these grand projets that were developed by Fuad Shahab in the early 60s, who hired Oscar Niemeyer, one of the pioneer architects in the period of modern architecture, who came to Lebanon and designed this beautiful complex in Tripoli as really a message of hope and of greatness for Lebanon and for the Middle East. Some 20 years ago, when I was an architecture student here at AUB, I discovered the fair with one of the experts in the field of modern architecture, Professor George Arbid, who literally took us to the site and allowed us to use it as a site for inspiration and to design a small pavilion within it. 15 years later, I went back to the site for a different purpose. I participated in a competition that was launched by the European Commission to renovate one of the pavilions, and it was the first time where an initiative of that sort took place, looking at the fair and at the potential of its renovation, but particularly looking at one abandoned pavilion that you see here in brown, to use it and to renovate it and to allow for it to become a platform to revive the dying wood-making industry of Tripoli. So the European Commission had identified a failure in the carpentry, I would say, profession, and really the craftsmanship that was completely dying since the early 2000s, and to find a way to revive it by going directly to the Tripoli Fair and allowing for Tripolitan carpenters to come inside the fair in this renovated hub, in this design hub, where the carpenters would actually meet with local designers and come up with furniture lines and design products that would be sold locally, regionally, and internationally. So it was a beautiful initiative. It's a project with a great impact, but it was very challenging for us as architects to intervene on a, number one, Oscar Niemeyer designed pavilion, but number two, to be able to complete it. Because the fair in itself was never fully sealed and completed. The construction started in '64, and at the break of the Civil War in '75, the fair was never actually fully completed at the time. So we went into really a process of research, an in-depth research, to really understand how Niemeyer himself would have completed the pavilion and its renovation. And this was the state in which we discovered the guest house. It's essentially a pure square in plan, punctured by a central pass-through that you see here, which is the only source of light of the pavilion. Another great source of inspiration was to look at similar buildings that were completed by Niemeyer himself at exactly the same time where he designed the guest house and the Tripoli Fair. Notably, one of them was the Itamaraty Palace in Brazil that very strikingly references an almost ornamental ceiling that is very comparable to the one that we have in the guest house. And it was really a great source of inspiration for us that helped us develop what we call the DNA of our intervention, which essentially sits into these three moments. Inserting a lightweight partition that would actually seal the courtyard from the rest of the spaces, introducing MEP infrastructure such as lighting, mechanical system, without really overcoming the architecture itself, and highlighting the structural elements such as Oscar Niemeyer would have done. So starting with the lightweight partition, there was really a series of iterations that were completed on site with local craftsmanship. We really tried as much as possible to work with local metal workers, local carpenters from the nearby villages of Tripoli to completely work on this renovation. And as you can see, the lightweight partition registers the ceiling grid vertically on this mock-up that you see on the left side, and ending in this very, I would say, subtle insertion, noting that every single piece of intervention that we did for the guest house is a reversible intervention. If the function was to change one day, everything can actually be taken away without hindering the original architectural intent of Oscar Niemeyer. So really an exercise in lightness and in thinness, using solid metal instead of aluminum to allow for this slenderness to actually reveal itself throughout this glass partition. The second element is really the highlighting of the structural element. We noticed that Niemeyer had really this preference, I would say, to clad every single structural elements in his building, notably in the Itamaraty Palace, by siding it with this plywood cladding that we decided to embrace and to really recreate along the 4 columns that surround the courtyard in the guest house. But not only that, essentially extending it vertically in this before and after condition along the main structural beam that really spans the entire length of the guest house and allowing to hide the electromechanical system. The third intervention really has to do with lighting, which was very, very challenging for us. How do you actually light an extremely horizontal space that only has one source of light in the middle of it? So really, again, the play of the doubling and the reveal to really play with the existing structural ceiling, the structural rhythm, and to create this doubling effect on the side of it, never really touching it. So we never actually touch the existing structural elements. We always stay away from these elements as much as possible. And we use these gaps and these reveals to actually insert, for example, here, directional tracks. The presence of a wall, which was surprisingly cladded by stone, and the use of stone is, according to us, a reference to locality and domesticity that Niemeyer himself decided to insert in his design as maybe a sense of really, again, domesticity and bringing in this domesticity in the space as a guest house. But really, for us, it was important to reveal it by introducing a new flooring that actually, again, stays away from it at the ground level, as you can see here on this image. And finally, really the landscape and how do you actually populate this internal pasture. So we looked at the work of Marx, who was a collaborator to Niemeyer at the time, and to understand the use of material as landscape. We noticed that there was a predominant use of gravel as a material, which is somehow a descendant of I would say, concrete as really a material that we decided to use as a floor covering in the courtyard, counterbalanced by these very playful, what we call lily pads that were actually planted, yielding into this very, I would say, serene space in constant dialogue with the interiors. A few photos of before and after, an extremely austere and linear building that surprisingly, as you enter it, is flooded with natural light. So really a very interesting play between shades and shadows. And it was really a beautiful experiment for us to be able to revive it. Today the space is used, very actively used, by a rotating team of carpenters into what is today called Menjara. So the European Commission now handed the platform to the René Mawad Foundation, who's managing it, and has proven to be very successful. They came up with these beautiful furniture lines that traveled the world in international exhibitions. Just a few extra photos of the renovated space. We were also inspired by some of Niemeyer's designs for furniture. And we were asked to actually design this reception desk at the entrance of the guest house, and it was a beautiful moment to see it lived and used on the opening day of the platform. These are a few of the collections that are being developed. It's also nice to see how the platform itself has created social impact and has responded to the economic meltdown, to the explosion of the port. 175 doors were repaired in this very platform after the port explosion. All the carpentry work of the Sursok palaces were also somehow reworked and developed at the platform with one of our colleagues here. And it's also, well, I'm ending somehow with the slide because what the platform is now moving into is maybe smaller objects, so it's really a response to the economic meltdown. So they're working on smaller wooden objects that are toys for kids that they are selling on their website. The project won the Aga Khan Award for Architecture just last year for its really, I would say, delicate renovation and really the great social impact that it has proven to show, and most importantly, to really the importance of preserving our modern heritage. Thank you.
Thank you very much. Well, with this, we come to the end of our program, but if there are any questions to any of our speakers, we'll be happy to entertain.
Okay, thank you for the presenters. I have two questions for the last two. So in Manjara, you showed the use of the spotlights. So just out of curiosity, the electrical supply or the HVAC systems, or so could you just elaborate more on like is there a utility? Usually you have utility floors or something like that. And for the previous speaker, also things related to, building management systems, CAF-AM, in terms of facilities management, and the use of the PCMs. Is there any research or, something along those lines? If you can elaborate more. Thank you.
Regarding the lighting, it was actually a lighting solution that looked at two options. One of them was to provide for general lighting, which is ambient lighting, through the use of these metal boxes that diffuse the light through this perforated sheet, coupled with the track lighting, which is more directional, that was catering for one of the spaces, two of the different spaces. One of them is an exhibition space where you actually need to light pieces, and the other one is at the material library where more, I would say, directional lighting would be needed on the actual materials. all of these systems are exposed, and actually the tubing that connects from these, the lighting fixture itself to the electrical board are all exposed in tubes and never really touching the exactly, yes, yeah.
Yes, thank you for the question. So for phase change materials, it is actually considered as any construction material. So traditionally, in the way it is used, has been used as any construction material like the insulation. It's actually employed in the same way. Now the system that, so the management system that is, it is similar to any other construction system, but the way we're now envisioning the new system, because it's the new, and we don't have, there's no research, it would be just like a part of the whole thinking that we will be employing as well. But no, there's no, because it's not existing now, and there's no research about that. And of course, this is another aspect that we have to consider or factor in when we think about the actual deployment of the system. There are, but these ones that are used actually are for the heat. So basically to reduce the, or actually to reduce the or increase the thermal barrier by increasing the thermal capacity of the wall.
All right, thank you very much, and hope you enjoy the rest of our program. Thank you.